head in the cloud or feet on the ground. So when they sent me an email asking me to give a keynote, I was thinking about what to talk about, and I came up with this title. And as soon as I sent out the email confirming the title, I sort of regretted it. Because I am not an expert, really an expert here. Even though this is a cool topic that I'm currently looking into, I don't have any papers working on cloud. So some of you who are here might be, know more about this than me. So, but please bear with me for the next half an hour. So I will start by telling you about what is cloud gaming. So how many of you know what is cloud gaming? How many have played games on any other cloud gaming platform? Some of you have. Okay. So this term came about around 2009. So this was during the Game Developers Conference. So there was a startup that gave a long presentation that generated a lot of hype in the press at the time. And this startup had been working 7 years in the stealth mode. And they come up with a company that promised to do the following. So they promised that with cloud gaming, there is no longer a need for you to download, buy CDs, and install games in order to play. With a click of a button, you can play the game, any game, on any time, anywhere, on any device. So this means that if you have a high-end video games that requires very heavy graphics, usually you need a high-power desktop or PCs to run the game. But here they promise that you can do this even on your mobile device. Okay? So you can run high-end 3D graphics on low-end device. And for game developers, they say this is good news for them, because now you no longer need to build your game for PC, for Mac, for Xbox, for PlayStation, for iPhone, for Android, and so on. So you just need to build one binary for all platforms. So how does this work? So let's look at what a computer game is. Right? If you think about it, it's basically a box where players put in user inputs into the computer games, right? Keyboard, mouse, controllers, and come out a sequence of frames. Right? So players look at the frames, and then they do more inputs, and then the computer game generates more frame outputs. Okay? So this is what a computer game is. Now, here I'm talking about a single player game. And this is running locally on a console, on a laptop, and so on and so on. Now, what is cloud gaming? Cloud gaming basically takes this box, the computer games, and then put it inside the cloud. Okay? So we now have two more software that's running. We have a team client, I call it cloud gaming client, that is running locally on the player side. Okay? And again, same thing, the user input goes in, out comes the frames, video frames. Now this user input gets sent through the network to a cloud gaming server. Okay? And the game, instead of running locally on the client, the game is running inside the cloud gaming server. Okay? And what the cloud gaming server does is that it takes this user input, that's transmitted over the network, pass it into the game, and then out comes the frames, and this sequence of frames gets sent over the network back to the team client and then displayed. Right? Now, of course, if you send one sequence of frames after another, it's natural to just compress this as a video and then stream this video over. And so, by running the game inside the cloud, right, we no longer limit ourselves to what games we can play on the client. Right? Because even if you have very high-end game, right? It's running in the cloud. So as long as the server is capable of rendering it, right, we don't care what type of client or what type of device you are running the client on. As long as it is capable of getting input, it's capable of decoding keywords. And even very low-end device is capable of receiving and decoding keywords, right? So that's the promise of cloud gaming. And of course, on the game server, you can run as many different types of games. All the latest game titles, you can put it, run it inside the servers, so you don't have to download and install games. So this is the promise in 2009. So what happened now? If you look around you, in the last 6 years, you might have heard some companies come up, some companies got bought out, some companies got bankrupt. So this hasn't caught on as expected. Why is that? Well, there are 3 challenges. The first is the lag. Now, if you play network games, you know that if you lag, it's a killer. Okay? Now, people have studied what are tolerable response time or tolerable lag for different types of games. All right. So for the first-person shooting game, right, where you have a first-person avatar, normally the cited number is like 100 milliseconds. So any delay from when the user put in the input to seeing the response of the screen longer than 100 milliseconds, user's performance will degrade. For first-person avatar, like role-playing game, it's about 500 milliseconds. For omnipresent games like real-time strategy games, it's about 1 second. Okay? So in order for us to play the games in the cloud, we must be able to have delay that are lower than these values. Okay? So let's look at what are the possible delays in a cloud gaming. Okay? So you have user input coming in. Okay? This gets sent to the game server and then go into the game software itself, and the outcome, the frames get transmitted, encoded as video, and then transmitted over the network back to the client. Okay? So I call this the client processing delay. Right? From this delay that is caused by the client itself, right, including buffering, decoding of the video. Right, this is called client processing delay. In the middle there, there's the network delay. Right? That's the time it takes to send the packets over the network and receive the video back. And on the cloud, you have what I call the cloud processing delay. So this is the time from getting the frame from the computer games, or even including simulating the game, the logic, the AI, generating the frame, encoding it as a video, and then send it. Right? So that's a cloud processing delay. So how big are these delays? So Chen and his colleague in 2001 did a measurement on the popular cloud gaming servers. And what they found is that on the client side, the delay is about 20 to 25 milliseconds, okay? Which is okay. But on the server, right, the time it takes to run the game, simulate, generate output, encode as video, that takes about 100 to 250 milliseconds. So as you can see, if we exclude the network delay, there's no way we can play a first-person shooting game, right, that requires 100 milliseconds or less in the cloud. Okay? Now, what about network delay? Well, there have been studies that shows for 3G Wi-Fi LTE networks, right, the 90th percentile network delay is in this range, right, 600 milliseconds, 300 milliseconds, and 400 milliseconds respectively. So now if you factor in this network delay, you can see that this round trip time from the user putting the input, right, move a mouse, for example, to see the effect of the input is going to take even more than 500 milliseconds. That is tolerable for third-person avatars type of games. So probably the only type of games that is user able to play the omnipresent type of games. Thank you. Okay. Second challenge is bandwidth. Right. So you can since we are sending video, streaming video over the network, for high definition video like 720p, we need about 5 megabit per second. Okay? And this is quite huge in terms of bandwidth. If you compare to typical online games, the downlink bandwidth is less than 0.1 megabit per second, which makes sense because for normal games, you don't send the video. What you send are the states. You send the information about which player is where, who has shot who, and so on. Right? So this takes very little bandwidth compared to sending the video. The third, which is a killer, is the infrastructure cost. Okay? So if we want to provide a cloud gaming service to many, many different players, each of them will need to run one copy of the computer games. Now, especially for high-end games that requires heavy, high-power computer graphics card hardware to render the game, okay, you need one server dedicated to running one copy of the game for one player. Okay? In fact, this infrastructure cost is cited as a major factor that caused that startup that I mentioned to go bankrupt, and now it's being bought over by Sony. So these are the challenges, right? So we have lag, we have bandwidth, we have infrastructure cost. So what can we do about this? Well, we can try to implement this in a more efficient way. Right? We can try smarter, faster implementation. And someone came up with a cloud gaming software called Gaming Anywhere. This is a open source software. So if you want to look into how it's done, if you want to play with it, you want to do research with it, you can go and Google this and download and play with it. Now, what they have done is they have able to reduce the cloud processing delay to about 25 to 35 milliseconds. Okay. Now, I tried to look up to what do these guys do differently that cause it to reduce the delay by so much. I look at the paper, and what they do actually make a lot of sense. But since we don't know how the other companies does it because it's closed source and proprietary, I have no way of knowing what are the things that they do right that cause the delay to be reduced by so much. Okay? But so this is one thing. We can reduce the delay on the cloud server side. We can also do a better cloud resource allocation. So suppose in the cloud you have multiple servers, and I have a player that want to play a particular game. Now I need to decide which server should I run this game on, right? So naturally, I would like to pick a server that is closest to me so that I reduce the network latency. But this doesn't mean that I reduce the total delay, because the delay also includes the time it takes to run the game, render the game, and so on. So in fact, there are multiple factors that are involved here. So suppose I'm a company. I want to minimize my cost of running a virtual machine running this game in one of the servers. Okay? So in different data centers, it might cost differently. Right? Amazon might charge me something different from Microsoft. So I need to put this cost into the consideration. I need to look at utilization of the CPU, the GPU, so that so maybe the one that is closest to the player is already overloaded. Then I should run this software somewhere else. We have to look at network conditions as well. So maybe, as you know, players play games, they don't play for 10 minutes, right? Usually, a real hardcore game player, when they sit down, they will play for hours and hours. So network condition will change, right? Maybe they play in the middle of the night, connection is good to a particular server, daybreaks come, people going to work, the network link become congested, maybe it's time to move this game to another part of the world or another server. And finally, we should consider also the quality of experience, which is encapsulated by the delay experienced by the user. So all of this has to be taken into consideration. So there have been some research work on this, on how to optimize the cloud gaming experience by choosing where to place a particular virtual machine on. Okay. But what struck me from this particular research work is that migrating a game is very expensive. So if you want to take a particular user virtual machine image that is running the OS and the game from one server to another, right? This virtual machine image takes about 20 to 40 gigabytes. And it takes about 6 to 11 minutes to completely migrate from one server to another. Okay? So why is this? Now this happens because we have been treating these computer games as a black box. And this black box just takes in user input and output from another frame. So if we want to migrate this game, we cannot migrate part of it. We have to migrate this whole box from one server to another. Okay? So this is the issue of why migrating a virtual image takes so long and it is so large. Okay, what else can we do? We can also try to improve the video coding efficiency to speed up the coding process and to reduce the bandwidth required. So one thing we can do is to do faster motion estimation. Now, just briefly, motion estimation is a process of video encoding where you take the previous frame and you take the next frame, and then you see where the pixels have moved. And then once you find out where the pixels has moved, roughly you say, when you want to encode the next frame, you say, okay, instead of encoding the pixels, you say, this set of pixels is similar to that set of pixels over there in the previous frame. Okay? So in normal video encoding process, this takes a lot of time because you have to go and search in the previous frame where are the closest or the most similar set of pixels. Now there have been some work that try to speed up this process by exploiting the game information. So what they do is that they look at camera movement and object movement inside the game, and this give them some hints about where to look for, right? To look for the closest pixel. So for example, in the game, they have a character that's moving from the left to the right. So to encode the next frame, they know that in the previous frame, they should search over here instead of search all over the place. Okay? And they're able to get about 10% speed up in total video encoding time without much loss in the quality. Another thing we can do with this game information is to do better bit allocation. Now, when we encode videos, we allocate to say, okay, this region in the frame you encode with so many bits. This region you encode with so many bits. And what has been proposed here by the same group as the previous one is that they try to utilize the attention model of our human eyes. So using the game information like the camera viewpoint and the object information, they allocate more bits to things at the center, to encode things at the center of the viewpoint, and for things that are closer to the player. So objects that are far away from the players or near the peripheral vision of the player, they are encoded with fewer bits. So meaning it's lower quality. Okay? But what they found is that using this method, they can get 50% reduction in the bit rate, which is quite significant, with only slight reduction in the mean opinion score, which is a subjective score used by the users to evaluate the quality of the video game. Okay? So these are reasonable methods to try to speed things up and reduce the bandwidth. But again, we have a problem here because we have been treating the computer games as a black box, right? Out go the user input, out comes a frame. Where do we get this game information and camera information from? Of course, you can build a new game that just specifically for this purpose, but then this means that your cloud gaming server, you cannot just play any type of game titles. You cannot just buy a game title off the shelf and then put it inside the cloud server. Because now you need a special type of games in order for these methods to work. Okay, let me talk about one more. What are things that we can do? So this is an idea that came out of Microsoft research. And what they try to do is to reduce the delay significantly for a player by pre-rendering future frames. So what they meant by this is that they try to explore all the possible next states. All the possible next states of the game. Okay? So for example, the user is now moving this way, right? And there are, let's say, three things that user can do. User can continue to move, he can turn left, he can turn right. And maybe the user can choose to fire the weapon or choose not to fire the weapon. Right? So there are 6 possible states. So now for each of these 6 possible states, we pretend that the user has done each of these 6 actions independently and then render the frames. So now we have 6 frames, 6 possible outcomes. Okay? And these 6 possible outcomes are all sent to the user. Now, these are all predictions. The user hasn't really entered the key yet. Right? So all these are sent to the user, and then when the user really enters the key, the user no longer need to send this input to the server and then get back the output. You already have the output there. It's just that we don't know which one. Right? So now that when the user chooses this, enter the key, we just pick the right frame, the right output, and then display that to the user. Okay. So by doing this, these Microsoft research folks show that they can hide latency up to 384 milliseconds, but at the cost of a 4.5 times higher bandwidth. And it's such a significantly higher bandwidth because now instead of sending one frame, you send multiple possible frames for the next actions. Okay? But the idea is that now my delay is limited to this, right? So user input, and then I just choose the actual output and then display. I don't have to go through the whole loop, go to the server and run the game. Okay? But now if you think about how you can implement this, now I need kind of like parallel execution of my game states, of my game simulation. I need different parallel execution. So now on the server, I not only need to run one copy of the game, I need to run multiple copies, each with different possible inputs and each with different possible outputs. Okay? And what's the problem? The problem is, again, we are treating this computer game as a black box that take what user input and video frame as the output. Okay, so there has been some research into how can we speed up cloud gaming, but we hit this bottleneck that make it practical, which is that this computer game is one giant black box. So here is the message for the talk, right? So I think there is really a need to pry open the black box and start to see what is inside. Okay. So my proposal is that we should have something called cloud-friendly game engine. Okay? So here's what I mean. So if you're computer games, you have this box. If you look inside, it's not really a black box. You have different things. You have the game logic, all the AIs, simulation, physics is there. You have the renderer. This is where it takes all the 3D stuff, render it. Right? And then you have the states. Now states you can divide into 2. You have the static states, which is like the map of the game world. And then you have the dynamic states, things that change according to the user. Right? You can treat these dynamic states as a per user states. Okay? So the proposal of making a computer game cloud gaming friendly is to make the per player states or per user states hot swappable. Okay? Meaning that given a game, I can dynamically say, okay, I want this player to run. I want these states to be inside this game. And then now you simulate the game for me. Right? And I want the same game, the same process, to run multiple parallel states. Right? Not only I say, this player, I can say, this game now you run for player 1, player 2, player 4, player 10. Okay? And we also like to support some database operations for internal game states. Okay? Now let me explain this in more details. Okay? So the green states here was the dynamic states, but now I make it into parallel. So now I don't only support one player, I say support multiple players. Right? Now the implication for the cloud resource management is that now instead of me migrating the whole game image, I just need to migrate the state of a particular player. And state of a player is much, much smaller than the game, the size of the whole state. Okay. Now, just now I also talked about pre-rendering future frames, and I can now have multiple possible future inputs, right? And I simulate it as if they are from different players, and then I can get multiple future frames outputs. The last implication is that now, if I want to speed up video encoding or reduce the size of the video, I can now query the internal states from the game. So instead of just thinking of computer game as just input and output, I can able to look inside and get a series of camera parameters from the game, for example, or from object information, or from semantic of the user actions, and so on and so on. Okay? So is this something really new? In fact, it's not. So my argument is that we know how to do something like this already. And what is that? Now think about a multiplayer game server, right? So you have a game server, we don't do rendering, so there's no rendering box here. But a multiplayer game server basically have states from multiple players running on the server, right? So you get input from different players, you simulate, you send the new states up to the different clients to render. So we already know how to do this, but it's just that now we try to do it differently. Instead of these players interacting with each other, each of these boxes here runs independently, right, without interacting with each other. Okay, so here are some of the questions. Suppose we want to build a cloud gaming friendly game engine. Right? What are the right abstractions to expose? What are the right states to expose to the user? Should all the game companies come together and define a common abstraction or common schema to represent the game state? Now, if you are a game developer, then how do you reduce the overhead for game developers? Well, people are used to building games in certain ways. Right? Now we have a new way for them to build the games. Can we reduce that learning curve and overhead? Now, doing this has some unintended advantages as well. So now that we have just one game running the game logic and rendering for different players, right? Can we share some computations? Maybe some of the AI computation that is heavy can be shared among the different players, right? Maybe the rendering of some complex object, we can pre-cache the rendering result from one player and then share with another. And these advantages come from running the states of simulating the different users together within one process. Okay, this is my last slide, and I'd like to end with this message that cloud gaming is very ambitious. People have been looking at cloud gaming servers and cloud gaming clients to improve the performance. Okay? But my message is that we should all together also look at making the game more cloud gaming friendly. Okay? So if you are doing research in game engine, if you do game development, think about this, or if you'd like to collaborate on this, if you want to talk more, please send me email or talk to me after this. I'll be happy to share my thoughts and work with you on this. And I really think that this is a new way of building games, because people either build single player game or multiplayer game. But now we are building multi-single player games. And I think the first companies that, the first game engine that does this has a lot of potentials in terms of improving the game performance in the context of cloud gaming. Okay, with that, I end my talk, and I'll be happy to take questions from you.